All right, just to get a little bit of extra factoring practice, we're going to work on this sheet that was given to you. So I'm going to walk through how all of these work, mostly using the box method that we've talked about in the past. So let's get started. So number one, you should always think that factoring always begins with the question, is there a GCF? Always ask that question first. Look for a GCF. Number one does not have one. So now I'm going to go to, since it's a quadratic trinomial, and I notice that the lead coefficient, the number in front of r squared, is greater than 1. This is when we utilize the box method. Personally, if this lead coefficient is 1, I don't think the box method is worth the time. I think it's easier just to look at the factors of the last number that add up to the middle. But you could technically use the box method for any trinomial that can be factored. So the way the box method works is you put the first and the last terms across from each other diagonally in your box. You're going to multiply those two terms together. And now we're looking for the factors of that product that when added together would give us negative 16r. And hopefully you recognize that that would be negative 18r and 2r. When you've identified those factors, you fill in the other squares, and it doesn't matter where you put those. You can switch those up and it won't affect your answer. Okay, and now to get our factoring, we're going to find the GCFs of each row and each column. So the top row, the GCF would be 3r, the bottom row would be 2. So that is one of our binomial factors, 3r plus 2. And then going vertically, this would be GCF of r, and this would be a GCF of negative 6. So r minus 6. And you notice equals 0 means not only do we have to factor, but we also have to solve. We've got to find out what those two solutions for r would be that would cause this equation to equal 0. So just take each factor. If you're not sure, you can always take each factor and make two separate equations out of them and solve each one of them for r in this case. So after you subtract 2 and divide by 3, you get negative 2/3 for one of your solutions. And then if you add 6, you get r equals 6 for the other. So there's your answer for number 1. Number 2, same process. We look for a GCF, but there isn't one. So once again, we're going to utilize this box method tool. And first term, last term, multiply those together. And look for the factors of 60k squared that add up to 19k. That's 15k and 4k. Put those in your other empty squares. Find the GCFs of each row and each column. So going across the top, that would be k, and this would be 1. So k plus 1 is one of your factors. And going this way, that would be 4k, and this would be 15. That's your other factor. It's a good idea to at least do a visual check with FOIL to make sure your factoring is right. You can always know for sure if you did the right factoring. So 4k squared would be first. 15k plus 4k is 19k. That's the outer and the inner. And then 1 times 15. So our factoring looks good. So now I've factored it, but if you see equals, that means you got to not only factor, but you've got to come up with the solutions. And the two solutions are k is negative 1 and negative 15/4. So if you didn't follow how I got negative 15/4, I just, again, made that factor equal to 0, subtracted 15, and then divided by 4 to get k. Number 3, I noticed that there is a GCF, so that needs to be priority number 1. Factor out the GCF of 3. All right, and now I'm going to do the box method on the trinomial, the quadratic trinomial in the parentheses. 2d squared, 3, 6d squared. Factors of 6d squared that add up to 5d would be 3d and 2d. And you fill those in. Find your GCFs, each row and each column. So that would be D and 1, 2D and 3. All right, and so now we can get our solutions because it is an equation. So D is -1 is one solution, and D is -3/2 is the other. All right, moving on to number 4, there's no GCF, so we'll get right to the box method. 2x squared -10, multiply those together, -20x squared. Factors of -20x squared that add up to +1x would be 5x and -4x. GCFs, x and -2. If both the terms are negative, that makes the GCF negative. This would be 2x and +5. So there's the factoring. And we're going to solve this equation using those factors. So one of my solutions for x will be x is 2, and the other one will be x is -5/2. The solution to each one of those factors equal to 0. Okay, we're ready for number 5. Look for a GCF. Don't see it. So box method again. A lot of good box method practice. All right, multiply those together. And the factors of -30x squared that add up to -13x would be -15x and +2x. Fill in your missing spaces, squares. Find the GCFs, 3x and 2, x and -5. There's your factoring. And I notice equals, so we got to solve. -2/3 is one solution, and +5 is the other. All right, number 6, another equation that has to be solved using factoring. So don't see a GCF, so we'll get right to the box method so we can break it up into two factors. First term, last term, multiply those together. Factors of -24x squared that add up to +5x will be 8x and -3x. Doesn't matter which order those go in. GCFs, 4x, -3, x and 2. And now we solve. So x is going to be 3/4, and x is going to be -2. Now, if you notice, when we get to 7, 8, and following, there's no equals. All right, so this is intentional. I want you to know when you solve. So if you see equals, that's called an equation. If you have an equation, you've got to solve for x or whatever the variable is. No equals, no equation, no solving. All right, all we have to do on 7, 8, following is do the factoring. All right, so I don't see a GCF on number 7, so I'm going to utilize the box method again. Multiply 8x squared times -27. I believe that's -216 x squared. And it is. And so now I'm looking for the factors of this product that add up to the middle term, -6x. And that would be -18x and +12x. So fill in your missing squares and find your GCS, both rows and both columns. GCF would be 2x here, 3, 4x, and negative 9. So 2x plus 3 times 4x minus 9 is the factoring. Again, without an equation, we don't have anything to solve, so that's as far as we need to go. And we'll do a quick FOIL check. 8x squared minus 18 plus 12 is minus 6. Minus 27 looks good. All right, number 8, we're looking for GCF. Doesn't exist. So let's try the box method again. Now I want you to notice in number 8, we're looking really for the factors of the end, which are positive, that would add up to a negative in the middle. So we've talked about this a few times, but it's easy to forget. If you ever see in your trinomial minus in front of plus, meaning multiply to get a positive and at the same time add those to get a negative, well, the only way that's possible is if both of the terms are negative. So for that reason, since we already know in our factoring both of the signs are going to be minus, I am not putting signs in the box. Okay, I'm just going to go ahead and fill out the two parentheses, the two binomials, and we'll just fill in the blanks with whatever the factoring ends up being. Okay, so the factors of 30x squared that add up to 17x will be 15x and 2x. So GCF across this way, 5x and 1. This would be 2x and 3. And so that ends up being the factoring. We'll check that out. 10x squared minus 15 minus 2 is minus 17. And then negative times negative is positive. So that's 5x minus 1 times 2x minus 3. All right, just a few more to practice factoring, perfect this skill a little bit. No GCF, so we're going to go right to the box method. Again, here's another example of minus in front of plus, so we can go ahead and set our factoring up with 2 minus signs. And then you don't have to worry about doing any signs in the square box. All right, so the factors of, multiply those together, factors of 15x squared that add up to 8x, of course it'll be 5x and 3x. So find your GCFs, 5x and 1. This would be 3x and 1. 5x minus 1 times 3x minus 1. Let's see if that checks first. Okay, good. Minus 5 minus 3 is minus 8x. That's good. Negative times negative is positive 1, and we're good. All right, number 10 is we're looking for GCF. I see that 4x is a GCF. Always look for GCF first. So when I factor out the GCF, I'm left with the difference between two squares in the parentheses. So there's a special way to factor the difference between two perfect squares. And there it is. It's the square roots of each term. One pair of square roots will get a plus, and the other one gets a minus. And that's it for number 10. Number 11 also has a GCF. It's 2. And then once we factor out the GCF, we have, once again, the difference between two squares. And there is our final factoring. So two things, factoring out the GCF and then recognizing the difference of two squares, special factoring case. All right, and then number 12, we don't have a GCF, but we do have the difference between two squares again. Both of these have perfect square roots and they're being subtracted. So it's kind of like this. You could just write the square roots twice, put a plus with one, put a minus with the other, and you are done. So that wraps up this little factoring practice exercise. I hope this helps, but if you still have questions about factoring, please let me know.